Hi everyone, this is a bonus walkthrough of a couple of puzzles I posted on June 1st alongside the normal gas. I filled in for Clover on June 1st. She was sick, and the puzzle I posted, this Squishdoku variant, I had never heard of until a couple weeks ago. On the CTC community Discord, where we post gas, we have a theory and programming channel that I spend quite a bit of my time in. Somebody raised the question of how many solutions does this variant have, and actually answered their own question, calculated it. And that got me playing around with the variant, seeing how restricted it is, and seeing what a minimal puzzle looks like. The absolute minimal puzzle for this type of variant, so this is a variant like a global constraint like anti-night, where we don't have anything distinguishing digits. So the only way we can make it unique is by placing given digits to make it unique. So the minimum you can have is 8. You need at least 8 different digits to be able to distinguish between 9 possible digits. And that's the case here. There is no 8 given unique Squishdoku, but there is a 9, and I was able to find one. So that's what this first puzzle is. The second puzzle is another Squishdoku that I made that is a little bit trickier. I know, seeing some of the postings on Discord and solve videos, it wrecked a lot of people. So hopefully I can explain what the thought process is there for solving it. But this first one, the 9 given puzzle, is not too difficult. It's on the same level as the gas I posted, maybe a little trickier. Anyway, what is Squishdoku? So already we can see we don't have a normal Sudoku. We only have 7 by 7, but we have digits going up to 8, and in fact we're going to place 1 to 9 in this puzzle. But the rows and the columns aren't going to contain every digit. The restriction on the rows and columns is they can't contain any repeated digits. So we're going to fill every cell so that it has a digit from 1 to 9. No repeats in the rows and columns, and no repeats in the 3 by 3 boxes. This is where the variant gets a little tricky and confusing. This is a 3 by 3 box in Squishdoku. And this is also a 3 by 3 box. And you'll notice both of those contain these 3 cells. So we need to place 1 to 9 in these 9 cells, and also in these 9 cells. These 3 are going to count toward both. This cell, this cell, this cell, and this cell count for 4 different 3 by 3 regions. So we have to keep that in mind when we're solving, that A, we can't have repeats, and sometimes we'll have a 6 down here and we're thinking about this box. We need to remember 6 is eliminating from all of these cells, because these are in the same box and these are in the same column. And also, we need to keep in mind that we do need every digit in each 3 by 3. All right, so how do we solve this? Let's start by the only digit that is duplicated in this puzzle. You can't get away with just 8 digits. You also can't get away with 1 of each 1 to 9 given digits to make a unique puzzle. Ranks checked that with his computer solver. So in this puzzle, we have 8 distinct digits, 1 repeated, and it happens to be the 3 because I put the digits in order when I filled them in. So in the central box, where does 3 go? Doesn't go in these cells or these cells in the rows, but it also doesn't go here because that cell is in the same box as this 3. So that's a 3. Where does 3 go up here? Well, all of these cells are in the same box as this 3. This 3 covers these cells, so this is a 3. And now we have 3 in this box, both of these boxes at the top. This one, this one, this one. We don't have a 3 down here. So 3 can't go in any of these cells or these cells. So we need a 3 in one of these cells. And then in this box, 3 can't go in any of these, or this one because of the region. So this is 3, this is 3. And that's all our 3s. And that kind of gets us going on the puzzle. We can also do some stuff with naked singles. What we have to be careful about is hidden singles. So if you haven't heard me use that term before, a hidden single is something like what we did with 3s. Where does 3 go in this box? It only had one place. That's a hidden single. In Squishdoku, we can't use hidden singles in the rows and columns. We don't know that every digit appears in each row and column. This row does not contain a 3, for example. So we can't use hidden singles for rows and columns. We can use naked singles anywhere. A naked single is a cell that can only contain one digit. So we're going to be looking at cells that are limited, and hopefully limited to only one digit. This might be one that you look at right here. It can only contain 1 or 9. It sees 2, 3, 4, 5, 6, 7, and 8. And in fact, all of these cells see the 3, 4 in the box, 5, 6, 7, 8 in this box. So these are actually from 1 to 9. And that's going to leave 5, 6, 7, 8 here. This would be called a naked triple. Just so you know the terminology. This can't be 6 or 7 here. These can't be 8. All right, now this cell needs a 4, a 7, or an 8 because the rest of the digits are in the row. Down here, we need 4, 5, and 6. This is not the 4. And it's also not 6 in the box. That gives us a 4, 6 pair down here, eliminating 6 here. One of these is 6. So now where does 6 go in this box? We have a 4, 6 pair here, so it's not in these cells. And it's not in these cells because 6 is in one of these. So basically we need a 6 here because both of these boxes have to be satisfied by a 6 in this column. This is 6. All right, what next? 8's going to go in one of these cells. 1 can't go up here, so 1's going to go in one of these cells. And now in this box, where does 1 go? Not up here, not here, and also not here because of this one. So this is 1. That makes that a 9. What do we have left here? 2, 5, 7, and 8. 5 can't go in either of these. So one of these is 5, which means this is not. So that's a 7. And now 7 can't go in these. So these are 2, 5, and 8. Now these are from 1, 4, 9. They can't be 2, 3, 5, 7, 8, or 6. This is no longer 7. And this can only be 8 or 9 because of the 1, 4 here. All right. Up here we need 5, 6, 8, 9. 6 is going to go in one of these cells. 5, 8, and 9. And that's going to give us a triple here. 5, 8, 9. Means we need 2, 4, 6 here. But we have a 2 in the row, so that's 2. 4, 6 here means this is not 6. So this is. And these will be 5, 8, and 9. I feel like I'm doing this in a completely different order from when I walked through it just 30 minutes ago. Anyway, 8 in this box goes in one of these cells. 1 goes in one of these cells. So this is 2 or 4 missing in the box. 7 over here can't go in these cells or this cell in these 7s. So this is 7. Nine is not in these cells, so 9's in one of these. I'm just missing something little at this point. 7 up here goes in one of these. That means this is going to be 5 or 9. This is 2, 4, or 8. This is 1, 2, or 4. Oh, the 1 here, that's been there for a while. 1 has to go in that cell. Because of this triple, we know 5 is in one of these. So 5 is not there. That also means 5 is not here, which we knew from this. Skip those. 8 is in one of these cells. So it's not here. Yeah, and it's not here either. We have a 4, 8, 9 here. So that's the 2. 2's not here. 2's in one of these cells. These are going to be the same. I don't remember doing anything with that. One of these is 7, one of these is 1, and we have our other 5, 8, 9 in here somewhere. That's the last little thing we're missing. 2 can't go in these cells, so down here 2 goes here. That's what we're missing. This gives us a 9, 4, 8, 9, 5, 8, and 5. These aren't 8, so this is 8. That's not 8 anymore, so this is 8. This is 1. This is 4 and 2. This is 6 and 4. 6 and 4 here as well from that 4. This is 9, since we have the 5 here. 8 can't go in these cells, so it's here. Which places 7 and 1, 1 and 2, and finally 5 and 9. And that's the solution. So not too bad. You can get tripped up by it, of course. It's a confusing variant. I've solved these a handful of times now, and I'm a little more familiar with it, but I'm still struggling to see things. So let's go to the other one. You'll notice this is in a different format. The gas was in this format. This was set in Pimpa. This was set in Sudoku Maker. And this is actually what I used when looking for the minimal puzzle, because it has a built-in solver. But I reformatted this in Pimpa and converted it to Sudokupad. This one I was going for sort of sequences of digits, 1, 2, 3, 3, 4, 5, 6, 7, 8, 5, 7, 9 for the odd digits. So where to start with this one? I mean, there are little things that you can do. 7 in this box goes up here. 5 in this box goes here. What else? 3 down here. I think those are all of our duplicated digits. Not super obvious where to start. Where we're going to start is here. This is a tricky step. It's just a property of Squishdoku. If you think about it long enough, you might spot this. You might just stumble on what you need to do some other way. But let's talk about the central cell in a Squishdoku. The central cell doesn't go in any of these cells, of course. And it also doesn't go in row 4 or column 4. So none of these are the green digit. Now, in each of these boxes, we have that green digit limited to 4 cells. There is a green digit in one of these, a green digit in one of these, a green digit in one of these, in one of these, and in one of these. And this works a little bit like a weird sort of jellyfish sort of thing. Not exactly. If we have a green up here, say, and it's not here, green here rules green out of these cells and the rest of this box, but and that places green in these cells. But that rules green out of these cells, placing green in these cells, and that rules green out of these cells, placing green in these cells. So this is one possible configuration of green. Obviously not both of these cells, but one in each case. The other option is that they're here, 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 and here. Those are the only 2 options. The important thing here is if we try and put a green up here, so we put it here, it's going to eliminate green from both of these. So now green in this region has to go in here, and in fact, in that cell specifically, and it has to go here. But now it can't go in these cells, and it can't go in these cells. And it can't go in these cells from this. So now we've eliminated all the possibilities for this box. Can't go in these cells from this either. So this box and this box do not have the central digit if we try and put green up here. And the same works for any of the corners. I said this is kind of like a weird jellyfish. It's also kind of the Squishdoku version of the Fistomothel ring, I guess. In that we're thinking about these corner boxes. The only digit that's not in this ring around the central box is the central digit, and it cannot go in any of these cells. That's the important thing. Okay. So if we know that, what is green? Well, now we know it's not 1, it's not 2 in the column, it's not 3, it's not 4 in this corner, it's not 5, it's not 6, it's not 7, it's not 9. The only thing it can be is 8. And that gets us going in the puzzle. This is really helpful. So we already know from our sort of windmill pattern that we got, 8's got to go in one of these cells, but we have an 8 here, so 8 can only go up here. Now it can't go in these cells, 8 can only go here. Now it can't go in these cells, 8 can only go here. And that's going to take care of 8s in all of the regions. All of these 8s are pulling double duty. And so we're done with 8. And we've got some cells filled in. So that is very helpful. All right, what do we want to look at next? There's some stuff we can do in the central box. So if we think about 5 here, 5 can't go in these cells or these cells between these two 5s. Also can't go here. So 5 is in one of these cells. 3 can't go in these or this. Very similar to the 5s. 7 can't go in these or this. 7 is up here. What about 4? 4 can't go in these cells. And it can't go here. So 4 is actually limited to these two cells in this region. But that's also going to apply here. We need a 4 here in this region. We need a 3 here in the central region. So we have a 3-4 pair. So that's nice. That rules 4 out of these cells, which we didn't know anything about for 4. What about 9? 9 in this region. A little more flexibility, but it can't go in these cells. So it's in one of these 3. In the central region now, it can't go in these cells. These two cells see all of these. These two in the region, this in the row. So 9's not in these. In this region, what do we have left? 1, 2, 6, and 9. Now, this is another slightly tricky thing to see. 7 is limited to these. But let's think about this cell. Much like with the pattern of 9s here, 9 ruled out of these cells, we have a 1, 2, 6, 9 quad here. And all 4 of these cells, which we know contain different digits, see this cell. So this cannot be 1, 2, 6, or 9. It also can't be 7. The only thing left is 3. What can this be? Well, it can't be 9, the digit that goes with the 7. We know there's a 7 down here. It can't be 9, but we know whichever of 1, 2, 6, 9 is here can't go in these cells, so it must be here. So this is not 9. This is not 9. This can't be 2. So one of these is 2, which means this is not 2. So this is from 1, 6, and 7. This one's not 1. That means 9 is in one of these cells, which means 9's not here either. We already ruled 9 out of these. So now 9 is in one of these 3 cells. We're eventually going to get it fixed here, I believe. What else? We can think about where 1, 2, 6, 9 go. In sort of the same way, and this digit. This digit could go in any of these. I don't think we can use that quite yet. Getting ahead of myself. 4 up here has to go in one of these cells. That means 4 is not here. Same sort of pattern there. Could be here. Oh, it can't be here because of the 3, 4 pair. Almost forgot about it. So now where does 4 go in this box? It's not here because we need a 4 in this column in box 1, and it's not here because of the pair, so it must go here. Like in the previous puzzle, it's satisfying the 4 in both of these boxes simultaneously, and it has to go there. 6 is not in these, so we're going to have a 6 in one of these cells. 6 in this box can't go in any of these cells, so we end up with a 6, 7 pair as well, matching our 3, 4. So this is not 6. These are going to be from 1, 2, 5, and 9, and this is not a 5. So now we have a quad here. That makes that 7, that 6, that 1. These are not 1, so this is the 1. This is 2, 6, 9 now, so this must be 7 and 1. These are 2, 9, and 6. The 6 must go here. All right. Up here, we need 5 and 6. We've got 5, 6 there. We've got a 6 in this row. This is the other of 2, 9. And now that we're going on this, we're making rapid progress. So there are some pairs to find, and there's some interesting little tricks. You'll see things like this in Anti-Night as well, where you have sets of digits that all see the same cell, and that contain different digits. Sometimes we call these unorthodox tuples. If you ever play around with Ranks Solver and see that, that's what it's talking about. 5 in this region. Can't go in these cells, and it can't go up here because we know 5 is in one of these cells. So this is the only place for 5. Just gonna get rid of the corner marks here. We are left with 1, 4, and 9 here. 1 can't go in either of these. So this is 4, 9. All right, we need a 2 in one of these cells. Five is taken care of here. What are we missing in this box? Got 1, 2, 3 is going to go in one of these. 4. So 4 can't go here. 4 also can't go here because it sees both of these. That also means 9 can't go here. So this is 2 or 7. It's the only thing it can be. And 4 is going to go up here somewhere. All right. 3 in this box. Can't go in these cells because of the pair. Can't go here, so it's in one of these. 9 we know is in one of these. We can do the same thing with 2, 9 here that we do with 3, 4. These can't be 2, 9. This one sees the row, this one sees the box. So these two cells see both of this 2, 9 pair. So those aren't 2, 9. This is not 9. But we already knew that one of these is 9 though. We know 2 is in one of these cells. I'm pretty sure there's something simpler at this point, but I keep seeing similar deductions. So we said 9 was in one of these in this box. But we can also get that with 2. The 2, 9 pair ruled these cells out. And this cell is ruled out by the 2 in this box. So this is a 2, 9 pair. 9. And so now 3 is limited to these 2 cells. 4 is limited up here. This can't be 1 or 6, so this is 3, 4. This probably would have been an easier thing to spot here. This can't be 1, 6. This can't be 1, 6. So we have a 1, 6 pair here, and the 6 resolves it. Down here we need 2, 3, 4, 5. These can't be 3, 4. So this is a 2, 5 pair, which makes that not 2. And this is 3 or 4. We're almost there. And now I'm looking for the last little deduction somewhere. The 9s again. So 9 is in one of these cells, and this cell sees both of them. Like that. So this is 4, this is 9. 2 and 9, 2 and 9, 2 and 6 and 9. This is a 7 now, with the 2 placed. These are 3, 9. This 4 is going to do 3, 4, 4, 4. The 2 gives us 5 and 2. Oh, 2 and 5. And the 9 down here gives us 3 and 9. That's the solution. So that took me a little longer. I know it took a lot of people a lot longer because there is that global trick with the central digit. And there's a lot of that sort of these 2 cells both see this sort of logic. Quite a lot of that in this puzzle. If you end up doing more Squishdoku, and I don't know how many of these have been made even, I know somebody's been posting them because it came up, but keep things like that in mind. This is a useful trick for all sorts of interesting variants with global constraints. Cells that see each other in weird ways. So anti-knight, anti-king, diagonal. But Squishdoku is another one where you end up with this sort of thing because some of the cells are in multiple boxes. So I hope you found those interesting. I hope you enjoyed them if you gave them a try. And I hope you found the walkthrough informative for this variant. I'll probably make some more of these at some point. They were fun to make and got some pretty cute logic. So anyway, let me know how you did in the comments if you tried them. Let me know if you want to see more bonus puzzles like this. We do the gas leak every month, give or take, when they actually get released. But we do a pack for every month containing the gas puzzles along with 5 bonus puzzles, typically, that are harder than normal gas. This is something that could have been in there, although I've seen some comments suggesting that this would have been too hard for that even. Maybe so. But I just posted this as a random bonus puzzle, and we could definitely do more videos of this kind in the future. So let us know, and I will see you next time.